Sustainable aviation fuel. Sustainable aviation fuel, SAF, is a type of aviation fuel that is produced from renewable and sustainable sources, with the aim of reducing the environmental impact of aviation. SAF is gaining prominence as the aviation industry seeks ways to reduce its carbon emissions and address climate change. Sustainable aviation fuel, SAF, is a groundbreaking departure from conventional aviation fuels, commonly derived from fossil resources like crude oil. It emerges as a response to the aviation industry's growing awareness of its environmental responsibilities and the urgent need to reduce its carbon emissions. SAF represents a crucial shift towards more sustainable and eco-friendly aviation practices. Unlike traditional aviation fuels, which release substantial amounts of carbon dioxide, Colorado-2, and other harmful pollutants into the atmosphere during combustion, SAF is designed with the environment in mind. Its production and use aim to minimize the aviation sector's carbon footprint and contribute to global efforts to combat climate change. SAF is engineered to achieve several key environmental benefits. Reduced carbon emissions. SAF is formulated to emit significantly lower levels of CO2 when burned in aircraft engines. In fact, it has the potential to reduce CO2 emissions by up to 80% compared to traditional jet fuel. Lower particulate emissions. In addition to CO2, SAF combustion results in fewer particulate emissions and other pollutants that contribute to poor air quality and respiratory health issues near airports and in populated areas. Sustainable feedstocks. The feedstocks used to produce SAF can be renewable and sustainable resources. These may include biomass feedstocks like agricultural residues, waste oils, algae, and even synthetic fuels produced using carbon capture technology. Compatibility with existing aircraft. One of SAF's advantages is that it can be used in existing aircraft without requiring any modifications. This compatibility allows airlines to integrate SAF into their fleets seamlessly. Why SAF? Environmental concerns. The primary motivation for SAF is to mitigate the aviation industry's environmental impact. Traditional aviation fuels are a major source of greenhouse gas emissions, and SAF offers a more sustainable alternative. Carbon emission reduction. SAF can significantly reduce carbon dioxide, Colorado-2, emissions, helping airlines and the aviation industry meet their emission reduction targets. Regulatory pressure. International and national regulatory bodies are imposing stricter emissions standards on the aviation industry, making SAF adoption essential for compliance. From when SAF being used? Current adoption. SAF introduction, early 2010s. The use of SAF in aviation began in the early 2010s, marking a significant milestone in the quest for more sustainable aviation practices. Initially, it was used in limited quantities and mainly for demonstration purposes to showcase its viability. Limited scale. During this early phase, SAF adoption was constrained by several factors, including higher production costs compared to traditional jet fuel, limited availability of SAF, and a lack of widespread infrastructure for its production and distribution. Demonstration flights. Many airlines and aviation stakeholders conducted SAF-powered demonstration flights to raise awareness about this sustainable alternative and to signal their commitment to reducing carbon emissions. Future expansion. Technological advancements. Ongoing research and development efforts are focused on improving SAF production technologies and efficiency. As technology advances, it is expected that the cost of producing SAF will decrease, making it more economically viable. Production capacity increase. Investment in SAF production infrastructure is anticipated to grow, allowing for larger scale production and distribution. This expansion will help meet the increasing demand for SAF. Regulatory pressures. Aviation authorities and governments worldwide are imposing stricter regulations and emissions reduction targets on the aviation industry. To comply with these regulations, airlines and aircraft operators are likely to increase their adoption of SAF. Market maturation. As SAF becomes more widely available and competitively priced, it is expected to become a more mainstream option for airlines. Airlines may enter into long-term agreements with SAF producers to secure a stable supply. Consumer demand. Passengers and consumers are increasingly conscious of the environmental impact of air travel. Airlines that offer SAF-powered flights may see a competitive advantage and increased demand from environmentally conscious travelers. Sustainability goals. The aviation industry has set ambitious sustainability goals, including achieving net zero carbon emissions by 2050. SAF is seen as a critical tool to help meet these goals. Driving its future expansion. Airports. Introduction at major airports. Sustainable aviation fuel is typically introduced at major airports that have the necessary infrastructure to handle SAF. Store it safely, and distribute it to airlines. These airports often have well-established fueling facilities and logistics in place. Logistics and distribution. Airports are key hubs for SAF distribution, ensuring that the fuel is readily available for airlines. They invest in the infrastructure required to transport SAF from production facilities to the airport fueling stations. Airline adoption. Airlines operating from these major airports have easier access to SAF and can more readily incorporate it into their operations. This proximity simplifies the logistics of fueling aircraft with SAF. Global adoption. Worldwide implementation. Sustainable aviation fuel adoption is not limited to a single region or country. It is a global effort to reduce carbon emissions from aviation. Recognizing that air travel is a worldwide industry with a shared environmental impact. Leadership in Europe and North America. Regions such as Europe and North America have been at the forefront of SAF adoption. They have implemented policies, regulations, and incentives to encourage the use of SAF within their aviation industries. International collaboration. International organizations like the International Civil Aviation Organization (ICAO) and industry groups are working to promote SAF adoption on a global scale. They aim to harmonize standards and encourage cooperation among countries to ensure the widespread availability of SAF. Emerging markets. While Europe and North America have made significant strides in SAF adoption, emerging markets in Asia, South America, and other regions are also recognizing the importance of sustainable aviation practices. These regions are expected to play a more significant role in the future expansion of SAF adoption. Who produces SAF? The production of sustainable aviation fuel, SAF, involves various stakeholders, including oil companies, specialized biofuel companies, and airlines, each playing a role in the production and promotion of SAF. Here's an explanation of who produces SAF. Oil companies. Role. Traditional oil companies, which have long been major players in the fossil fuel industry, are increasingly diversifying their energy portfolios by investing in SAF production. They recognize the growing demand for sustainable and low-carbon aviation fuels. Expertise. Oil companies have substantial experience in fuel production, distribution, and infrastructure, which can be leveraged to scale up SAF production. Sustainability goals. Many oil companies have established sustainability goals and commitments to reduce their carbon footprint, and SAF production aligns with these objectives. Biofuel companies. Role. Specialized biofuel companies are at the forefront of developing and producing SAF from renewable feedstocks. These companies are dedicated to creating sustainable alternatives to fossil fuels for aviation. Expertise: biofuel companies possess expertise in biotechnology, feedstock sourcing, and advanced conversion processes required for SAF production. Research and innovation: they often engage in extensive research and innovation to optimize SAF production methods and explore new feedstock sources. Airlines role: some airlines have taken a proactive approach to sustainability by investing in SAF production or forming partnerships with SAF producers. This enables them to secure a sustainable fuel supply for their aircraft. Leadership: airlines that invest in SAF demonstrate leadership in sustainability and a commitment to reducing their carbon emissions. They set an example for the industry. Demand stimulation: by becoming early adopters of SAF, airlines can stimulate demand for sustainable aviation fuels, which can, in turn, encourage further investment in production capacity. These stakeholders often collaborate to create a sustainable SAF supply chain. For example, an oil company might partner with a biofuel company to produce SAF from renewable feedstocks. And airlines may commit to purchasing a portion of their fuel from these producers. Additionally, government incentives and regulations can further drive collaboration and investment in SAF production, supporting the aviation industry's efforts to reduce its environmental impact. Overall, a collective effort from various stakeholders is essential to the growth and sustainability of the SAF industry. How is SAF produced? Feedstock collection, source selection. SAF production begins with the selection of suitable feedstock sources, which can include biomass, such as agricultural residues, algae, waste oils, e.g., used cooking oil or animal fats, municipal solid waste, natural gas, or carbon capture and utilization technologies. Collection and processing. These feedstock sources are collected and processed to extract the necessary raw materials for SAF production. This process may involve crushing, refining, or other pre-processing methods. Conversion. Choice of conversion method. Various conversion methods are employed to turn the processed feedstock into SAF. The choice of method depends on the feedstock type and availability. Common conversion methods include hydroprocessed esters and fatty acids, HEFA. This method converts vegetable oils or animal fats into SAF through hydroprocessing, resulting in a fuel that is similar to traditional jet fuel. Fischer-Tropsch synthetic paraffinic kerosene, FORT SPK, FTSPK produces SAF from gasified feedstocks, like natural gas or biomass, using the Fischer-Tropsch synthesis process. Alcohol to jet, ATJ. ATJ technology converts alcohols, such as ethanol, into SAF through dehydration and catalytic processes. Power to liquid, PTL. PTL technologies use electricity, often derived from renewable sources, to produce synthetic fuels, including SAF, by combining carbon dioxide, Colorado-2, and hydrogen, H2. Usage. Airlines and aircraft operators can use SAF in their aircraft without any modifications to engines or infrastructure. SAF is compatible with existing aircraft and can be used as a drop-in replacement for traditional jet fuel. Certification. To ensure the quality and safety of SAF, it must undergo rigorous testing and meet specific standards established by organizations like ASTM, American Society for Testing and Materials, and ICAO, International Civil Aviation Organization. Certification ensures that SAF is suitable for use in commercial aviation. Distribution. SAF is transported from production facilities to airports, where it is stored in dedicated fuel storage tanks. Specialized logistics are required to handle SAF, but it can share distribution infrastructure with traditional jet fuels. Overall, SAF represents a promising solution for the aviation industry to reduce its environmental impact and work towards a more sustainable and eco-friendly future. Its adoption is expected to increase as technology and infrastructure continue to develop, aligning with the industry's sustainability goals and global efforts to combat climate change. Till then, catch you in the next one.